Okay. So, next problem, you guys. We're still on this section that's mole to grams or mole to mass and mass to mole, okay? The first problem that we did and the second problem that we did together, they were examples of mole to mass problems. In other words, that what we started with was moles and what we were ending with is grams. Now, in problem number 3, you're actually going to see that we're going the opposite direction. This time, the quantity that we are given is a gram quantity, and we are asked to solve for how many moles, okay? So what we're going to have to do is we're going to have to go in the reverse direction as what we were doing in the previous 2 problems, okay? All right, so as with all of these problems, what did we say is the very first thing that you need to do? What do we need? We need a balanced what? Equation. We need a balanced equation. Okay? A balanced chemical equation. It says, consider the decomposition of mercury 2 oxide, HgO, to form, so we're decomposing HgO, to form elemental mercury, which is just Hg, and oxygen gas. What's the formula for that oxygen gas going to be? O2, because remember we said that's one of our diatomic elements. Brinkelhoff, okay? Oxygen is the A in Brinkelhoff. So oxygen is a diatomic element. All right? So there's our skeleton equation. Is this equation balanced? No, this equation is not balanced, okay? We've got 1 mercury on the left, 1 mercury on the right, 1 oxygen on the left, 2 oxygens on the right. So the oxygen isn't balanced. We've got 2 on the right, 1 on the left. How can I get 2 oxygens on the left? Add a coefficient of 2 in front of the HgO. Now that throws off our mercury, so how do we balance our mercury? Coefficient of 2 in front of the mercury. You got it. Now we've got a balanced chemical equation. Okay? Next, underneath that balanced chemical equation, we write what information we are given and what information we are solving for. So we are given 125 grams of oxygen. Okay? We have only 125 grams of oxygen that are going to be produced. The question is, how many moles of the mercury 2 oxide do we need to use in order to produce 125 grams of oxygen? So remember what I said earlier. It doesn't matter the quantity that you are given. It doesn't matter whether it's on the left or whether it's on the right. Okay? Doesn't matter at all. You can go between 2 reactants, 2 products, a product and a reactant and a product. The technique is always the same. It doesn't matter where you're starting in the balanced chemical equation. Okay? But this time what we're starting with is a gram quantity. And if I want to be able to go from one side of the equation to the other, we said that to go from one substance to another substance, regardless of where it is in the chemical equation, we have to be in what unit? To go from one substance to another substance, what unit do we need to be in? Nope. Moles. We need to be in moles. To cross over from one substance to another substance, we've got to go through the land of the mole. So we've got to get this 125 grams, we've got to get that into moles. So to convert grams to moles, we need to use what? Just like converting moles to grams. What do we use to convert between grams and moles? We need molar mass from, where do we get that from? The periodic table. We need the molar mass of that substance from the periodic table. But this time, I'm converting from grams to moles instead of from moles to grams. When I was converting from moles to grams, I multiplied by molar mass. What am I going to do if I'm trying to go from grams to moles? Divide by molar mass. That's exactly right. So we start with 125 grams of oxygen. We've got to convert that to moles using the molar mass of oxygen. 1 mole of oxygen has a molar mass of 32.00 grams. Okay? I just get the molar mass of oxygen off the periodic table, which is 16. multiplied by 2 because there's a subscript of 2. The subscripts count in the molar mass, but the coefficients do not count in the molar mass. Subscripts get factored into molar mass. Coefficients do not get factored into molar mass. Okay? So we've converted from grams to moles. Now I can go from moles of one substance to moles of another substance. I can go through the land of the mole. Okay? So now what I need is the mole-to-mole ratio between the oxygen and the mercury 2 oxide, the HGO. All right? How many moles of oxygen, looking at the balanced chemical equation, how many moles of oxygen are in that balanced chemical equation? What's the coefficient for the oxygen? 1. The coefficient for the oxygen right here is 1. So 1 mole of oxygen, and I'm going to put that on the bottom. Why do I need to put the oxygen on the bottom and not on the top? We want to get moles of oxygen to cancel out. That's exactly right. So now moles of the HGO is going to go on the top. So based on that balanced chemical equation, what are the number of moles of HGO? What's the coefficient for the HGO? 2. 2 moles of HGO are required for every 1 mole of oxygen. So now we're ready to type into our calculator. In our calculator, it's going to be 125 times 1 times 2 divided by 32 times 1, if you want to include the 1. Okay? So, how many significant figures did we start with? 125. How many sig figs is that? That's 3 significant figures. So we're going to do 125 times 1 times 2 divided by 32. And my calculator shows me 7.8125, and that is moles of HGO. Okay? But I need to round that to 3 significant figures. So 1, 2, 3. How does that 2 tell me to round my 1? Up or down? 2 tells me to round down. So this ends up rounding to 7.81 moles of HGO. And there's my final answer.